Hey guys, IT Guy Michael here and welcome to another lecture of our classification in Python tutorial or course on Skillshare. In this lecture we're gonna talk about numerical data. In the previous videos I show you the basics of evaluation. We were talking a little bit about precision, recall, F1 score. If you still are lost in these terms, go there, check out the lecture again, write down the comment, I'll be glad to answer your questions. Now in this video, let's go to the Jupyter Lab, the notebook, and as you can see, again, there are a lot of libraries which we're gonna use. Most things are imported from scikit-learn, which we're going to use just for evaluation, and the important part is here these modules like standard scalar, polynomial features, min-max scalar from scikit-learn, which we are going to use. So whenever you will go through the code and you will use something which I'm not defining here, go to the top and check the libraries which I'm using and the modules which I'm using, and make sure you import the same things as I do. For the versions, I will create the requirements.txt file on the Git, linked in the description below, so please go ahead and install the same libraries. I'm running it in the virtual environment of the Python tree, so basically the standard process. Now, I am reading the numerical data into the DF, and as the same as in the previous video, I'm splitting the Y vector of predicted values and the matrix of the target features outside, so I'm splitting them outside. And then first I'm printing this hist. I already printed it in the exploratory analysis notebook over here, but right now I'm doing it here just to recap what we did. So I showed you here these distributions. So here we can see distributions of our data, and now we are going to play a little bit with these distributions. So let's say we want to first talk about normalization. So in this case, we want to rescale the data or put it into different distributions. And first, let's talk about min-max normalization. So the min-max normalization will ensure us that the data will go from the distribution as it is into the range between 0 and 1. So this is very helpful for some types of classifier, let's say logistic regression. I know many of you don't know what is logistic regression. We'll talk about it later, but just you need to know that sometimes you need to rescale the numerical data in order to improve the classification, right? You can create the classification with the data as you have, as we saw in the previous video, the previous lecture. But to improve the classification, yes, to get the better recall and precision, you need to play a little bit with the data, and rescaling the numerical data is one of the options. So let's rescale that with the min-max scalar or the min-max normalizer. So the formula for this is that you want from the x, which is the given row or the given value, subtract the minimal value from all the x's in the feature, and then you want to divide it with the max of the given feature minus the min of the given feature, right? So basically we are just subtracting the minimum from the value, the minimum of let's say you have we can display it on the example. Let's say you have like 1, 2, 3 in the these are the features. Let's say these are the values for the age. I know this makes no sense, age is not so small, but let's say it's for age. So for each of the row you will do the equation like minus the minimum of this vector, which is in this case 1, and then you will divide this thing by a maximum of this, which is 3, and minus the minimum, which is 1, and you will do the same thing for each of it. Like here you will put it there. Whoa. Here you will put the same thing instead that you will put here number 2, and here you will put the same thing instead you will put here number 3, right? And when you will run this, you will see that each of the values will be between the 0 and 1. You can play with the values which you want. You will end up within this range. Now, when you got here, for example, the years at company, you see that they are starting from 0, going up to 40. And when you use the min-max scalar, this will do this transformation for you. So how to use it? You will create an instance of min-max scaler. You can import the min-max scaler from the scikit-learn preprocessing tools, right? Always, if you don't know how to import it, put it into Google, and the first result will be mostly the documentation. So go ahead and check it out. So we are creating the min-max scaler, and then we are calling the normalizer is the min-max scaler to function which is called feed transform. And basically the feed transform is the same function as the feed in the previous case, but instead of just, you know, training the classifier, in this case it will also transform the data. So result equals normalizer feed transform, and because you know these scalars needs to work with the NumPy arrays, and they need a special, like they are accepting only the column vectors, not the row vectors. You need to reshape the values of the panda series. This is just a technical detail. Please copy this. I will show you later how to use it easily. So, but the thing is, I'm putting it here just to demonstration that when I run the min-max scaler upon the years at company, I need to extract the values and reshape this into the column vector. So if I put it here outside, you will see that, oh my gosh, you will see that this command is just, oh yeah, I didn't run this. So just don't forget to run those, take some time. Yeah, just to plot these, right? And here is, you can see that I'm creating just the column vector as an input to the normalizer, and then I'm just reshaping back the column vector into the series, just so I can have like the output for the histogram. Now you can see that the histogram went from these into these, starting from 0 going up to 1. So this normalization, or the min-max normalization, can be very helpful for certain classifiers. Now again, there is not like a golden rule for everything. The application of different normalization tools depends on the classifier which you're gonna use through the prediction. So this is what makes a good data scientist a good data scientist. Knowing what classifier needs what is the essential key to success in the data science and in the machine learning. So please note that this is a tool and you can use this tool. At my beginnings, it was just experimenting. Whenever I was running some classifier, I was always trying the min-max normalizer and other normalizers, which I can present you here in this video. Now, another approach which is quite common is called the standard scaling, or the Z normalization, where we are transforming data into normal distribution, so to resemble the normal distribution. This operation centers the data around mean of 0 with the standard deviation, right? So it keeps the standard deviation and it centers the data around the 0, so they range from minus something up to 1, but the mean is always 0. Now the equation for this is here, so we are just like subtracting the mean, which is the u, and divided by the standard deviation of the row. So when you have the row of ages, let's say, you compute the mean, and then you just divide it with the s. So for example, this is the year of the company, right? This is the mean, and you can also get the standard deviation down there. But the simplest thing to show you is just, you can create an object which is, so this is the original again, and you can create here the object which is called standard scaler, and then you feed in these data and feed transform it, and as you can see, the center is around 0. Now the most important thing, so this is the Z normalization. It's quite popular. You can use it with your data to improve the scores. Now, but the thing is, like, right now I showed you how to transform the whole X, but you can whole X with the one column, right? But you can transform the whole data frame in one run. So let's say you have a whole data frame, right? And you want to transform and scale, or using the min-max scaler or the standard scaler, the whole data frame. So you create the scaler, right? The way how we did it here. And then you run the feed transform upon the whole data frame. And this will end up in creating the data frame, the new data frame, right? So here I'm transforming the whole data frame, adding it into results, and then because this will, so, oh, sorry, let me just show you. So the x is in this case a data frame, right? But when I run the scalar, I'm so sorry, scalar feed transform x, so this one, I didn't specify, I didn't run this. So let's get the standard scalar, put it here, and then feed transform this one. You will see that the output is an array of array. It's a numpy array. So if you go, but the shape is the same as the x. So this is the shape of this, and I can here print x shape, right? So the same shape. And now because this is an array of array, I want to do the print of the histogram. I need to convert it into data frame, and that's the reason why I'm putting it here, the constructor of data frame, and then printing it like this. And as you can see, everything was centered around 0 with the Z normalizer, right? Now, let's go next. So beware of the future scaling. So what does it mean? So as you can see, by running the standard scalar here, we were extracting or subtracting the mean. But you still need to have in mind that this mean is calculated from the training data, yes? So you want to transform also the test data, right? Right now I was showing how to run it on the whole X, but you need to extract the mean and the standard deviation, or the min max in case of min max scalar, from the training data and apply this transformation on the test data, right? So please always be sure that you are not extracting these values from the whole dataset. And when you are splitting it to train to test, always separate the train and test. And now I will show you how you can do it. So the whole, so beware the future scaling, right? I create here the scalar, and now I'm splitting the x by the 80-20 rule into x train, x test, y train, y test, right? And then look at this. I want to learn the scalar, the standard scalar, the mean and the standard deviation from the train data. That's the reason why I'm using fit. Whenever you use fit, you are saying that learn something, right? In case of before, in the previous video I showed how to learn the classifier, I was using just fit, but I want to also transform the x train data, so then later I can put it into the classifier. And then in case of test, I'm running a method which is called a transform, right? So this way the learn, mean and standard deviation is being used for transforming the x test here, right? Skip time to absorb this information, go through the example, you can try it on your own. Always rewrite the code, don't copy it from the GitHub. Sorry. The polynomial features is the next issue. So you have these, this array, or sorry, you have this data frame of features, right? Like age, let's look at that. You have this data frame of features, sorry, we are just running. So like X, so you have here the age, distance, education. Yeah, I showed you how we look at the linear dependencies and the correlations. And sometimes the thing what helps is to multiply one column with another. Now, when I talk about help, I mean like it can improve the performance of the classifier later. Now, to apply this combination of columns, something which is called polynomial features is being used. Now, to create a polynomial, you need two columns, right? So to apply the polynomial features. So let's say you have a column A and B, and when you apply the polynomial features upon them, the result of the polynomial is like the column A, the column B, the column A times A, the column A times B, the column B times B, right? So we are like artificially creating new columns in this data frame by multiplying the old columns, right? So let's go to the example, right? So let's suppose you have a data frame with these two columns, right? And now you will just go and apply the polynomial features of the second degree to this data frame. So I'm using the fit transform. And here, as you can see, the first column is just the 1, right? It's always the 1. And then there is the A. Sorry, the first column is the A. Is the 1. The second column is the A. Then there is the B. This is B. Then there is the A times A. This is 1 times 2. And then there is the B times A. Sorry, this is the A times A, then A times B, and then B times B, which is the last column, right? So I automatically create all the combination of these columns and add it to the end of the data frame. Now you can do this for the whole data frame and create combinations of each of the columns, and this can very significantly improve the performance of some of the classifiers. Now, by applying this fit transform for the whole data frame, right? So I showed you how to normalize things, how to create the polynomial features, and let's test what's the impact on the final results. So first, I'm splitting the x and y of the dataset, and this is the same prediction from the last. So this is the first prediction, so the prediction of numerical data without any normalization or polynomial features. You can see the results here. And now, what I'm doing here, I'm creating a polynomial features of third degree, right? So there will be another 8 on the third, on the degree of 3 and stuff like this. And I'm applying the standard scalar. So first I'm applying the PF transformation, so creating the polynomial features. I'm adding it here. Then I'm adding the scaling, fit, and then I'm transforming the test data, always test data after the train data. And then I'm applying k-nearest neighbors for the scaled and transformed data, and I'm predicting on the test of scaled and transformed data. And as you can see, the results, I will put it here. So the output here is like, the precision is the same, right? So we are fine. But the precision on the one, on predicting whether somebody will go or not, is lower in this case, but the recall is much higher. So not much, but on 3% higher, right? So what does this application of transformation does? What did it improve? The performance of the recall of the variable 1, right? So the point of this is like sometimes applying some modifications and transformation may improve something in your classifier and sometimes not. You need to try all the other possibilities and you need to play with these to get to the point. This is the work of the data scientists and machine learning engineers to try some combinations of different applications of the data transformations to reach the better results, right? In the next videos, I can show you also how to make it even more funnier. I have also the example of the min-max scalar. So if you look at the min-max scalar, the recall is even higher than here. Wow. So the min-max scalar was very helping with these predictions, right? Okay guys, this was a little bit about numerical features. I hope you learned something new about, I don't know, scaling and normalizing and creating polynomial features. In the next video I will talk a little bit about categorical features. Thank you very much for watching. I hope I will see you in the next video.